Welcome again. In this episode of CHeM In 3, we look at the expression pH is equal to the negative log to the base 10 of the molar hydrogen ion concentration, and the fact that hydrogen ion concentration can be determined by this expression, 10 to the power of negative pH, and how these two can be related to this, the ionic product for water, in solving problems where Kw, the ionic product of pure water, is equal to the H plus concentration multiplied by the OH negative concentration, and that comes to 1.0 by 10 to the negative 14 moles per dm cube. So we look at how to solve problems involving any one of these three given any of the other two. Suppose we wanted to find the concentration of hydroxide ions, OH negative, in this milk sample, which has a pH of 6.70. To determine the hydroxide ion concentration, the OH negative concentration, we first solve for the H plus concentration, using the expression H plus is equal 10 to the negative pH, which comes to 10 to the power of negative 6.70, and that works out to be 2.0 by 10 to the power of negative 7 moles per dm cube. Next, we consider this expression for the ionic product of water, and we substitute the known value for H plus into this expression, and we make OH negative the subject of this formula. Solving, we divide the ionic product for water by the concentration of H plus, and we end up with this value, 5.0 by 10 to the negative 8 moles per dm cube, as the concentration of hydroxide ions. But to solve this problem, there's also a shortcut, and if we use this expression, pH plus pOH equals 14, then we can say that if pH is 6.7, then pOH is 7.3. And using this expression, OH is equal to 10 to the power of negative 7.3, we will get the very same value, 5 by 10 to the power of negative 8 moles per dm cube. And now I would like you to try this problem. A cup of coffee has a pOH of 8.9. What is its H plus concentration? And I'd like you to use both methods to solve the problem.